resistance in a voltage source connected in series while the internal resistance in current source is connected in parallel. So a voltage source, according to ChatGPT, is like a pump that keeps the voltage constant. Inside it has some resistance, internal resistance, because no source is perfect, right? This resistance affects the flow of current. When current flows, the voltage drops slightly due to this resistance. To show this effect, we imagine this resistance as being in series with the voltage source because any current leaving the source must pass through it. The resistance is in series because any current must pass through it. Why does any current must pass through it? I think of it like a water pipe with a pump. The pump sets the pressure, but the pipe has a bit of blockage that slows the flow. That slows the flow current. Okay, and a current source is like a pump that keeps the current constant. Inside it has some resistance which allows some current to leak internally instead of going to the load. Resistance is modeled in parallel with the current source because the current splits between the resistance and the external circuit. Huh? This resistance is modeled in parallel with the current source because the current splits between the resistance and the external circuit. Imagine a fountain pump. It pumps water to the fountain load, but some water might leak back into the pump through a bypass parallel resistance. Okay, so why this difference? I somewhat get it, but still I'm not very clear. And the voltage source, the internal resistance affects the voltage because it directs the current flow, so it's in series. And current internal resistance affects how much current leaks away, so it's in parallel. No, I still don't understand it. Understand why resistance is not connected in connected is not connected in current source in series and vice versa. This is to maintain a flexible voltage. The resistance represents unavoidable resistance inside the source. Any current that flows through the circuit must also flow through this internal resistance. This resistance causes a voltage drop, which directly affects the output voltage delivered to the circuit. The voltage drop depends on the current. To model this behavior, we replace the resistance in series with the ideal voltage source because both share the same current path. Why not in parallel? If it were in parallel, some current would bypass the circuit and go through the resistance, but this is not how voltage source works. The resistance does not leak current, it causes a drop. A current source is designed to deliver a fixed current. The internal resistance here represents imperfections. Not all current reaches the load because some of it leaks through the internal resistance. Okay, I finally get it. Finally. The internal resistance provides an alternative path for the current. The total current splits between the load and the resistance according to Kirchhoff's current law to model its behavior. The internal resistance is placed in parallel with the ideal current source because both share the same voltage across them. So why not in series? If the resistance were in series, it would limit the current based on Ohm's law. This would mean the current source could no longer maintain a constant current, which contradicts its design. Visual analogy. Imagine a water pump connected to a pipe with a narrow section internal. The flow of current through the pipe causes a drop in pressure at output. The narrow section. Since all the water flows through the narrow section, the resistance is in series. And imagine this pump now has a bypass valve that leaks some water back to the pump instead of sending it all to the fountain. This bypass is in parallel with the main valve because it provides an alternate path for the water current. So resistance in series because it causes a voltage drop to proportional to the current. The voltage source has a resistance series, and the current source has resistance in parallel because it leaks some current away from the load. Somewhat. Yeah, it makes some sense now. In some sense, somewhat. Let's see what it says. Battery service on. No problem. Want to feed this one. So okay, so this resistance represents the narrow section of light. Must flow through the narrow section before it becomes drop the pressure. Drop the voltage. So resistance some water might flow back into the load. This bypass leaks water, which changes how much water reaches the load. Okay. Okay, that's it. I prefer this response, and I hope that you guys also understood because I somewhat understood that. That's it for today. GG's. That's it.